Hello. So this is a video on about the assignment of Sajibuddin sir. So for the A section, this is the assignment given. It says that an aluminium square thin plate having dimension of 1 meter each side is exposed to the environment. If the temperature is maintained at one boundary at 400 degrees Celsius and the rest are 100 degrees Celsius, then determine the temperature distribution over the plate at steady state using ANSYS. So basically it's a square thin plate of aluminium material, and the three sides here is shown to be at 100 degrees Celsius each, and only the lower part of the edge or the surface of the thin plate is at 400 degrees Celsius. So we are to make a simulation of the temperature distribution upon the plate using ANSYS. So to start that, I'm going to workbench. Okay. So first of all, as it was said that I have to simulate this in a steady state condition. So using the steady state thermal, dragging it to this box, and as you can see, this problem is probably a 2D case. So you can simulate this simulation both for 2D case and 3D case. I will be showing them both. So first we are going for a 2D case. So for a 2D case, go on the geometry, and you should see a project schematic on the right side of the screen, and you can change the simulation type to 2D. You can see mm, the properties here are shown. Okay, so you will not be accessing that geometry changing type here. So just go to the geometry box, right click on it, and you should see a properties option. Go here, and you should see analysis type, and you should change it to 2D. And it was mentioned that it is an aluminium square thin plate. So by default ANSYS will have a structural steel, but we are to include the material of aluminium in this engineering data. So go here, click here, and right click edit, and go to click here to add new material, and go to the data sources and choose, scroll down and choose for thermal material. You should see thermal materials, yes, and you should see aluminium in the first 8 table. So select that and choose plus option, and you should see a bookmark here. The bookmark here means that the aluminium property has been added into the ANSYS project schematics. So now go to the geometry. By default I am using design modeler. Alright, so choose any plane, go for a new sketch, go for sketching, and make a perpendicular view, and or you can just go for a create concept cross section rectangle. That should be easier way. So now just give the dimension of 1 meter, and this should also be 1 meter. So this is the sketch. Now we will be making a surface from out of the sketch. So go to create, and not create, actually concept. Go to concept and choose surface from sketches, and select apply. Select this rectangle and then apply. Okay, sketch 1. Alright, so to make a 2D sketch, you would be not be able to make a surface just out of this cross section. You need to sketch it. So let me try it again. It wouldn't take it. So no problem. Just delete this. It will be applicable for 3D simulation as well. So I'll be taking the sketch one. I have to sketch the plane here. So go for sketching, choose a rectangle, and give it the dimension. Keep on it general. Give the dimension as 1 meter, and give this dimension as 1 meter as well. and go for constant and for choose symmetry. Now choose the symmetry axis first, and while tapping your control key, select these two side. Similarly, to reselect the symmetry, go for dimension and then again go constant. Now you can select the symmetry option, select the axis, and while tapping the control key, select these two and it will be symmetric. Okay, and now we'll be generating a surface from this sketch. So go to concept, surface from sketches, and apply this sketch, apply, and you should be adding material and generate. And this is the surface of the thin plate. Now it is time to give the name selections. Now go for the edges, select this edge, name selection, call it upper. Similarly, I'll be naming all the 4 edges, calling it just simply left. Name selection, calling it right, and generate. And finally, the bottom edge, this should be called the lower. Generate. So our geometry is done. Now go to the workbench and go for the model edit. You should be seeing starting mechanical here. Okay, so this is the geometry of ours. We do not need this cross section anyway, it won't make any problem. Just go to the geometry and should see drag and go to the surface body and refresh, update, coordinate system, stiffness, structural steel, change the assignment to aluminium. It should be okay. Now generate a mesh. I'm going for a default mesh, so just go for the mesh here and generate. If you want to find mesh it, you can also do it, but I am not won't gonna be do that here. Now for giving the boundary constant to this thin plate, I will be choosing the steady state thermal option, right click on it and insert temperature, and now change it to name selection, choose the upper one and give the temperature to 100 degrees Celsius. Similarly, right click temperature, change it to name selection, change it to left and 100. Again insert temperature, change it to name selection, change it to right. Only the lower part will having the temperature of 400 degrees Celsius. So name selection, go for lower, and the temperature is 400 degrees Celsius. And as we will be seeing the temperature distribution, go for solution. Wait a minute, to show a problem mark, lower. Okay, right click in solution, go for thermal and temperature, and now solve it. And you should see a similar type of temperature distribution in this plate. Now if you assume a 2D case, then it is enough, but there is no mention in the assignment problem that it should be a 2D or 3D case. So if we are to simulate a 3D case, then the process will be a bit different. I will show that to you now. Now you might want to save the project before moving on to the 3D case, and this 2D case I have saved it here already. So I'll be opening a new file in the workbench. So similarly, I will be choosing the steady state thermal, and this time I will not change the geometry type to 2D anymore. It will be 3D. And just before going there, I will be changing the material, or adding the material of aluminium. So right click, edit, click here to add new material, go for the data sources, choose thermal material, and you should see aluminum, and edit again, go in the project and make the geometry first. Now for the geometry, I will be choosing any random plane, xy plane, and for this plane I will be creating a cross section of a rectangle and give it a dimension of 1 meter and 1 meter, and now I will be extruding it. Mm, okay, so for the cross section, go for extrude. I will be showing the process again, as it had a problem before. Delete, yes. So I have a rectangle cross section, rectangular cross section of 1 meter and 1 meter. Go for the extrude and apply. Now I should add the geometry as rect 1, and you can see it as well, and give it the depth of only 0.001 meter, almost 1 millimeter thickness for 1 by 1 cross section. So that would be a very thin plate, and now generate. And similarly, I will be choosing surfaces for naming these 4 surface. So carefully choose not this surface right here. It will be looking at as an edge, but it is actually a surface, a thin, very thin surface. So right click, name the selection, call it left, and generate. Similarly, choose all the surfaces, very thin surface, carefully. Name selection, upper, generate, and now this surface, right click, name selection, this is right, generate, and finally the lower one, name selection, lower, and generate. So this is our geometry is done. Now we'll be moving to the simulation of, or modeling the simulation. In the main time, the 3D simulation of this whole panel will include the convection and radiation as well. While we are doing a 2D case, we were only accounting for the conduction issue, but this time we will be taking all those heat transfer modes, all those 3 heat transfer modes, and do a complete simulation of this problem. As the assignment, there is no mention of 2D or 3D case, so we are free to choose any of them. So if you want to stick to the simpler model, just do for a 2D, but if you want a complete model, so go for a 3D and choose all the heat transfer mode: conduction, convection, and radiation. So go to the workbench and edit. Now before going anywhere, choose the geometry and go for the solid, and change the assignment to aluminium, and now generate a mesh. I'm still going for a default mesh, and now the temperature, Now similarly, beforehand for the 2D case, likewise the 2D case, I will be choosing the name selection that I have done before in the geometry section, and choose the left side, give it the temperature of 100 degrees Celsius, insert temperature, name selection, upper, it is also 100 degrees Celsius. Now temperature, name selection, right, 100 degrees Celsius, and the last one is at the lower name selection. The lower is just 400. Wait a minute, I misclicked one. Lower, now it's okay. Now in addition to add a convection and radiation boundary condition as well, I will be choosing these two surface, this surface and this surface, as for radiation and convection condition. So insert convection and choose these two surface, this surface and this surface. So while clicking your control key, select this surface and this surface and apply. And I have seen in the internet that the film coefficient is just the convection coefficient of still air. As I'm imagining a still air of 22 degrees Celsius, the film coefficient should be 5 watt per meter square degree Celsius. And similarly, add a radiation boundary condition. Similarly, apply the two phases that I have applied in the convection condition as well, and apply. And it is the correlation is to ambient, and the emissivity, normal emissivity of aluminium is just 0.1 to 0.24, so I am choosing a 0.2 emissivity, and it should be okay. And the ambient temperature is always 22 degrees Celsius, it's the default condition. And now similarly, just insert a thermal temperature probe and solve. So if you consider the convection and radiation heat transfer mode as well, so the temperature distribution looks like this, and the average comes out to be 97.547, whereas for a 2D case the average temperature was 147 or something like that. So you can see a very low temperature as the average degree Celsius, because the heat transfer will be also occurring for convection and radiation as well, and thus it should be the actual heat transfer for this thin plate if we consider the outer environment as well. So if you want to save it, you can save it. Just go to the file, go for save project, and writing arbitrary name. So it is almost done. You can just take the picture as many as you want with different configurations. So I will let it be on your side. Just go for a better view. You can change the views or the configuration type from this edges part. Choose any of them you like. Okay, so I guess it is okay. I do not need to write any videos or any file, so just we can take a screenshot or save pictures, and the lab report should be written just I mean the assignment report should be written as we have written the lab report. So this is it. Okay.